I'm Anil Kumar, and in this video we will understand how rate of change is related with slope, average rate of change and instantaneous rate of change. So we'll try to find the connection between them. Let's begin with a small sketch. Let me sketch a quadratic function to explain the idea. So let's say this is the quadratic function for us. I'm taking a very simple example. Let us say equation for the quadratic function is y equals to 3x squared. So parabola has vertex at origin and y equals to 3x squared is the curve shown here. Now, if I draw a line connecting 2 points on this parabola, for example, let's say we have a line like this. And let us say these are the 2 points on the parabola. Let's call these points as A. And let x value be 1. If x is 1, 1 square is 1, 1 times be 1, 3, right? And let's say this point is 3 for us, right? So 3 square is 9. 9 times 3 is 27, correct? So that becomes 327, right? So let us say these are 2 points A and B. So if you connect a line with these 2 points, it will be a straight line, right? What is the slope of this line? So we have slope of line AB. Let me call this as MAB, right? Slope of AB will be, as you know, change in y over change in x, which is y2 minus y1 over x2 minus x1. So we can write this slope m of line AB as equal to 27 minus 3 divided by 3 minus 1. So 27 minus 3 is 24 divided by 2, or slope of 12. So it's a positive increasing line with a slope of 12. So that is what we understand as a slope of a line, right? Now this line, when we talk in connection with the curves, if a line cuts a curve at 2 points, then those 2 points in this fashion, then we call that line as a secant. So we also call this line as a secant. So the slope MAB is also slope of the secant, right? Now, average rate of change is the slope between when 2 points are given to us, right? So when we say average rate of change, we say slope of secant. So in this particular case, average rate of change of y value, this is the y value. So here, average rate of change of y with respect to x. So we say average rate of change of y with respect to x is the slope 12 here, right? Is the slope of secant. Do you understand? So that becomes the average rate of change. Okay, so slope of secant is average rate of change. Now if I have to find instantaneous rate of change at a point, let's talk about instantaneous. At a point, and let's consider that point to be, let's say, A for us, right? Instantaneous means slope of tangent. at that point. So that is how slope, secant, and average rate of change and instantaneous rate of change are connected. So what really happens is, when we say instantaneous rate of change at a point A is slope of tangent. Now consider bringing this point B closer and closer, closer and closer. Then we'll have a situation where practically the secant will become a tangent that is kind of like this. Do you see that? Touching A at just one point. So slope of this is instantaneous rate of change. Slope of secant is average rate of change. Do you see that? So that is how they are related. The concept here is that instantaneous rate of change is difference between the 2 points, and we now say is between A, which in our case is 1, 3, and another point, let me call B dash, which is very close to A. That is to say, 1 plus, let's say, delta x or h units apart. Just that much. Then the value of the function, the y value will be f of 1 plus h. Is that okay? So in our case, if I have to find slope at A of the tangent line, that is to say instantaneous rate of change, I could write this as the change in y values, right? So that is also delta y over delta x. The only thing is that change of delta x is very small, right? So we'll write this as f of 1 plus h minus f of 1 over h, where, let me write in a different ink, h is very small. We say the term limit h approaches 0, or we could say h is very, very less as compared to 1. So either we write this or we say that. One and the same thing. Do you understand the concept? So let me just find instantaneous rate of change at 1. So when I say f of, let me write down here. So we'll use the term limit for the time being. You could use this term also. 1 plus h, the formula is 3 times x squared. So it becomes 3 times 1 plus h whole square minus, if I write 1 here, I get 3. So I get value at 1, which is 3, divided by h. Is it okay? If I expand the numerator, what do I get? I get 3 times 1 plus 2h plus h square minus 3 over h, where the limit, right, in different ink, h approaches 0. Is it okay? So if you open this, 3 and 3 cancels. So we are left with limit h approaches 0. So if I open this, we get 3 plus 6h plus 3h square minus 3 over h. Is it okay? Which is limit h approaches 0. 3 minus 3 is 0. So we're left with 6h plus 3h square over h. Now h can be factored and cancelled, right? So we get this as limit h approaches 0. So I can factor h out. I can factor 3 also, but I'm not doing it at present. 6 plus 3h over h. Now h and h cancel. Do you see that? Let me push this a bit here. Once we cancel, and h is very small, substituting 0 here, we get 6. So slope of the tangent at A is 6. So I'll say instantaneous rate of change at x equals to 1 is equal to 6. Do you see that? So when the point B comes very, very close to A, secant becomes a tangent. And average rate of change becomes instantaneous rate of change. Do you see that? And we can find its value as shown in this particular case, right? So you can also see from the diagram the slope of tangent is much lesser than that of the secant. It comes out to be 6 with our calculations, right? So I hope you understand and appreciate how slope, average rate of change, and instantaneous rate of change are connected. We'll do some examples to elaborate on this process, which is also called difference quotient method. Let me write down here. It's called difference quotient method, right? Quotient means division, right? So means division. Difference is delta y over delta x. That is difference quotient. This is basically delta y over delta x, change in y over change in x. I'm Anil Kumar, and I hope that helps. Please feel free to share my videos and write your suggestions. Thank you and all the best.